If we take an example of a table of length and width 1 meter into 1 meter, as I told you, the pressure exerted by air in downward direction is greater than 100,000 pascals, as I am showing you here. Then why not the table collapse under this huge pressure? How does it handle such massive pressure acting on it? Because atmospheric pressure applied on any surface is equal in all directions. If the pressure applied downward, that is equal, pressure is applied from down towards upside, okay? Downward, upward, from left side, from right side, okay children? Because atmospheric pressure applied on any surface is equal in all directions. Since atmospheric pressure on a table is equal in all directions, pressure acting in opposite direction cancel each other. That's why the surface of the table not collapsed. Now, to understand the existence of atmospheric pressure, generally we are doing an activity in laboratory. But as we are going through virtual classes, so we will try to understand verbally. What we will do, children? For this, we will take a metallic can which is having an airtight stopper, okay? Fill it partially with water and start boiling it on any burner. Generally we are doing in a laboratory, okay? So what happened at that moment? What happened? The air pressure inside the container and outside the container both are equal, right? Okay. But this steam takes out driving out all the air which was inside the container till that moment. Try to understand. All the air which was present inside the can driving out with the steam. Now what we will do, we will switch off the burner and put the stopper or the lid on the can, and then we will replace this can inside a tub which contains cold water. Then what will happen? As we will put this tin can inside the tub which is having cold water, this steam condensed into water droplets. Then what happened? Then there is a partial vacuum and air pressure is still applied from the outside, but there is no inside air pressure or negligible air pressure inside the container. That's why when you will pour water inside it, or when you will put the can which is heated inside the tub, it collapsed. This is the proof that there is air pressure. So if you want, you may start writing in this way. Let's see how we'll start. To understand the existence of atmospheric pressure, we will do this activity. Crushing can experiment. Step 1. We will take a tin can provided with airtight stopper. Okay. Step 2. Remove the stopper. We have already removed the stopper from here. That was the cover. Maybe the shape of that stopper is like that. Okay. So we have removed because we were boiling that liquid. And fill the can partially or half with water. Step 3. Heat the can over the flame of the burner till the water begins to boil. Air pressure here in this situation, air pressure inside the can is equals to air pressure outside the can. Here you can see the diagram, what are the things I have drawn here. This is the metallic tin can. Steam is coming out, liquid air, this is liquid, that is water, air pressure applied from this side, that side, and from all the direction. Wire gauge, this is wire gauge, burner. This diagram is for what? It is air pressure inside and outside the can is same. Now step 4, when the steam starts coming out of the opening, put the stopper and remove the can from the burner. See, we put the stopper back to its place, we covered it and removed from the burner. Now we brought it, kept it in a tub, and we are pouring cold water, and here is also cold water. So step 5, place the can in a tub and pour cold water on the can. What is the observation? We will notice that the can collapses. Can you see that? This is our second diagram. You are also supposed to draw the diagrams. This was our can, which was earlier in proper shape. We brought it here, kept it inside the tub, and now pouring the cold water. Stopper is here. All the steam condensed into the water droplets. Air pressure applied from outside is more. See here, air pressure outside the can is more than inside. That's why the can collapse because of the so much pressure from the outside as compared to the inside. Okay, so what is the observation? We will notice that the can collapses. Fine, children. So this is the one proof where we can see the example that yes, there is presence of atmospheric pressure. And I have chosen this example just because this is given in your book. Otherwise, we can take another examples also from our daily life. So what you will write as conclusion? As we notice that tin collapsed, the reason behind it is that steam has driven out with it most of the air from the can. When cold water is poured, steam condenses into water, leaving a partial vacuum inside the can. The air pressure from the outside is more than that from inside, and this excess air pressure from outside exerts force due to which can collapses. Okay, so here your conclusion is finished. Now I'm going to start this thing that what is the standard value of atmospheric pressure, because we knew that the atmospheric pressure decreases with altitude as we go to a height above the earth's surface. If we knew that, then what is the standard unit? What is the standard value of atmospheric pressure? Because earth is not a smooth surface. Few where we have seen that hills are there, mountains are there, desert area, the hilly area, then the valleys are there. It means different heights, different altitude. People are living at different altitudes. So what is the value we will take at standard value? For that, what we are doing at sea level, whatever is the atmospheric pressure of the air, that will be taken as standard atmospheric pressure. Okay, and what is that? Atmospheric pressure is equals to 76 centimeter of mercury column. What is that? As we are using thermometer to measure the temperature of the environment or our body, for that what we are using, there is a thermometer. Similarly, there is an instrument that is barometer. With the help of that we are measuring the atmospheric pressure. In general, at sea level, atmospheric pressure always is about approximately it is equal to 76 centimeter of mercury column. Means height of the mercury is up to 76 centimeter at sea level. I am talking about sea level. That is, we are taking that value, we are taking as standard value. Okay, and this is equals to what? We consider it as 1 atm. Atm is atmospheric pressure, and that is equals to, if you want to understand in the form of Pascal, then it is 1 atm is equals to 1.013 into 10 to the power 5 Pascal. In general, we are using direct 10 to the power 5 Pascal to get the approx value. Okay, so you may note down this one also as note. The atmospheric pressure decreases with altitude as we go to a height above the earth's surface. Why?